Section 2.1 Frequency distributions, or can also be called frequency table, shows how data are partitioned among several categories or classes by listing the categories along with the frequency of data values. Let's try an example to see how frequency table works. This is the data of the lunch service times of McDonald's by seconds. This is 107 seconds, 139 seconds, 197 seconds, 209 seconds, and so on. To put this data into a frequency table, we will have the first column is the column listing out the variable, which is time in seconds. This is called classes. 1, 2, 3, 4, 5. I have 5 different classes. The first classes contain the time from 75 seconds to 124 seconds. The second class is from 125 seconds to 174 seconds, and so on. To find the frequency for each class, we will look through the table and count to see how many of them belongs to each class. Let's start with the first class from 75 to 124. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The second class is the class from 125 to 174. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. The third class is the class from 175 to 224. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The third class is the class from 225 to 274. 1, 2, 3. And the last class is the class from 275 to 324. 1, 2. If you add all of the frequencies up, the total should be equal to your sample size, which is 50. Relative frequency distribution. Each class frequency is replaced by a relative frequency, or proportion, or a percentage. To construct a relative frequency distribution, we first need to have the frequency. To find the frequency for the first class, I am going to take 11 divided by 50. To find the relative frequency for the second class, I am going to take 24 divided by 50, 10 divided by 50. Three divided by 50. And 2 divided by 50. If I add all of these numbers up, I will have exactly 1. If you've been rounding off these numbers, your total might be a little more than 1 or a little less than 1. It depends on how you round these up. Relative frequency can either be in decimal or percent. So you can always convert these decimal to percent if you want to. And the total of these percentage is equal to 100%. Lower class limits are the smallest numbers that can belong to each of the different classes. For example, each of these classes will have different lower class limits. 75 is a lower class limit for the first class. 125 is a lower class limit for the second class. 175 is a lower class limit for the third class. 225 is a lower class limit for the fourth class. And 275 is the lower class limit for the last class. Upper class limits are the largest numbers that can belong to each of the different classes. For example, 124 is the upper class limit for the first class. 174 is the upper class limit for the second class. 224 is the upper class limit for the third class, and so on. Class boundaries are the numbers used to separate the classes, but without the gaps created by class limits. For example, if I want to find a number that's separating the first and the second class, the number should be in between 124 and 125. That should be 124.5. If I want to find a number to separate the second and the third, then the number should be in between 174 and 175. It should be 174.5. Class midpoints are the values in the middle of classes. Each class will have different midpoints. To find the midpoint for each class, you take the lower class limit, add the upper class limit, divided by 2. To find the midpoint for the first class, I will take 75 plus 124 and divide it by 2. To find a midpoint for the second class, I will take 125 plus 174 and divide it by 2. To find a midpoint for the third class, I'll take 175 plus 224 and divide it by 2. And I'll do the same thing for the last two classes. class width is the difference between two consecutive lower class limits in a frequency distribution. To find the class width, we are going to choose two consecutive classes. It can be the first and the second, or the fourth and the fifth, or the second and the third. It doesn't matter as long as the two classes are consecutive. So for example, if I choose the first and the second, and then I am going to take the lower class limit of these two. And if I take 125 minus 75, I get the class width. Example 2. I have the list of 50 data. These are the duration times in seconds. So 125 seconds, 203 seconds, 205 seconds, and all the way to 264 seconds. This data is sorted from the least to the greatest. And they want me to construct a frequency distribution. They want me to use a class width of 25, and the lower class limit for the first class is 125. So I have a table. The first column is my variable, and the second column is my frequency, because they want a frequency distribution. They want the first class will start with 125 as the lower class limit. So I will start with 125. And they want my class width to be 25. What I am going to do is go ahead and list out all of the lower class limit by taking 125 and keep adding the class width, which is 25. 125 plus 25 is 150, plus 25 is 175, plus 25 is 200, plus 25 is 225, plus 25 is 250. Next, I am going to list out my upper class limit for each class. So to determine the upper class limit for the first class, I'm looking at the lower class limit for the second class. So this is 150, and I'm just going to determine a number that's less than 150, which is 149. To determine the upper class limit for the second class, I'm looking for the number that's less than 175, which is 174, and so on. I stop at this class because I noticed that my largest value is 264, which belongs to this class. That's how I know when to stop. For the first class from 125 to 149, I only have one value. So the frequency is 1. From 150 to 174, I don't have any, so frequency is 0. 175 to 199 has a frequency of 0 as well. 200 to 224 has 3. 225 to 249 is 34. And 250 to 274 is 12. If you add all of these up, it should be equal to 50. B. Construct a cumulative frequency distribution. In order to construct a cumulative frequency distribution, we have to have the frequency distribution. So we are going to use this distribution in order to construct the cumulative frequency distribution. So with the first class right here, we are looking from everything that's less than 149. So we have less than 149, which is 1. And then for the second class, we are going to look from 125 all the way to 174. So everything less than 174. So we are looking from 174 and all the way up to 125. So for the cumulative from this all the way up to the first class, we take 0 plus 1. Moving on to the third class, we're looking from 125 all the way to 199. So everything less than 199. Moving on to the fourth class, we're looking at everything from 125 to 224. So that is less than 224. So we take 3 plus 0 plus 0 plus 1. For this class, we're looking from 125 all the way to 249. And then less than 274.